Hey guys, here's your review for Spiral 2. The formatting is going to be a little wonky just because we are looking at a Word document here, and this should be a little bit easier to read because I'm not using my phone today, which is nice. First up, let's talk about right triangle trig. And we've got to solve the triangles below. In other words, we've got to find all sides and all angles. In the first guy, I know two different sides. I might figure out the third side by Pythagorizing, and when I do that, we get the square root of 7 squared plus 8 squared, and that is going to be 49 plus 64, something like 113, which is awesome. I love it. I can just leave it like that. So this side is the square root of 113. That's about as far as I can go there. As far as getting some of the angles, I might arbitrarily choose B first. Compared to B, 8 is going to be my opposite side, 7 is going to be my adjacent side, and square root of 113 is going to be my hypotenuse. I could use any of this information in order to figure out what B is. I'm going to choose 8 and 7 because those are easier numbers to type in on my calculator. And my relationship with an opposite and adjacent is going to be tangent. I might start by writing that the tangent of B is equal to 8 over 7. Okay? And that also means that the inverse tangent, or the arctangent, of 8 over 7 is equal to whatever that angle is. And when I use my calculator to figure that out, we get that the angle should be about 48.814 degrees. Okay, for B, we have an angle and a side this time. I'm going to use that angle as my base point. And there's my opposite, my adjacent, my hypotenuse would be down here. I don't really care what I figure out next. I could go for this angle, and I know that triangles have to add up to 180. I also reminded myself in doing that I have to do the same thing for the one above. So these two pieces have to add up to 90 to make that true, and that would have to be 40.5 to make that add up to 90. Jumping back up to A, I never actually figured this guy out, so that would be 90 minus 48.814. And I am feeling a little bit lazy, so I will do that on the calculator as well. And in doing that, we get 40... Ooh, I just was about to put that in the wrong place. So 48.814. And angle A would be 41.186. And that gets you what we need for that. Moving back down to the problem we were working on. So we've got an angle. Now I've got to figure out some sides. I'm going to use B because I already circled it. And I might start by thinking about I know the adjacent, and if I want to know the opposite, I might use tangent. So the tangent of 49.5 is equal to the opposite, I'm going to call this the OPP, over 10. Wow, this is being awful today. And when I find that value out, so in other words, tangent of 49.5 degrees, I get 1.17 is equal to the opposite over 10. Multiply both sides by 10, and we get 11.7 is equal to the opposite side. So that's up here, 11.7. I might Pythagorize to get that third side, or I could use sine or cosine. It doesn't really matter. But when I do that, I should get something like h is equal to the square root of 10 squared plus 11.7 squared. And that is not going to be clean, so I will actually do that one as a decimal, so we get 100 plus 11.7 squared. Syntax error. Ooh, let's see what I did. I didn't use a plus. And we get the hypotenuse is equal to 15.3912. Moving on to the word problem. Okay, we've got Jimmy hiding in a tree, and Andre sees him. I'm going to draw a picture to represent that. Here's my tree. Here's Jimmy in my tree. Andre is somewhere over here. He's standing 50 feet from the tree, and the angle is 20 degrees. We're going to assume that's the angle of elevation going from his feet, and that's going to be 20. Where must Andre position a 24-foot ladder in order to have the top reach Jimmy? I'm going to do this in blue. So somewhere we're going to do a 24-foot ladder here in order to make the top of that reach Jimmy. It might be helpful for me to know what this height is in order for me to do this. So let's kind of break some of this stuff down. First thing we have to do is figure out what that height is. I'm going to use my angle of elevation. I'm going to use the distance that Andre is from the tree. And since we're looking at opposite and tangent, well, opposite and adjacent, that's a nice Freudian slip there. I'm going to use tangent. Seems to be a very tangent-filled day today. So in looking at this, we're going to say that the tangent of 20 is equal to the opposite. And I labeled that y, so we'll call it y over 50. Okay, tangent of 20 is 0.3639. I'm going to multiply that by 50, and that equals y, which is 18.1985. Okay, so now we know the height, which is 18.1985. I'm having the worst time with writing on this today, and I don't really know why. Okay, now I've got to figure out this new triangle. So I've got this guy. That's my 18.1985, and I know it's got to be 24 feet of ladder. So what I need to do is figure out how far from the base of the tree I want to place that ladder. The simplest way for me to think about that is probably Pythagorean Theorem, and that would be that x squared plus 18 point, let's just call it 2 squared is equal to 24 squared. 18.2 squared is going to be 331.24. If I do 24 squared minus that value, we end up with x squared is equal to 244.76. And when I square root that, we get x is equal to 15.6448. Wow, this is terrible today. So somewhere in the order of 15.6 feet away is where I should place this ladder. Okay, moving on to laws of sines and cosines. We're going to try to find the indicated measurements. And we've got to identify if we need to use potentially more than one measurement or not, any if it doesn't work at all. The way that I'm going to do that is to take a look at the angles first. In the first triangle, I've got 61, 30. That very quickly says my last angle needs to be 89. Since I know all three angles, we don't have to worry about more than one triangle. That only happens if we only know one angle. I've also got a nice opposite pair here. So this is going to be a law of sines 1 because that's easier to use if I have opposite pieces. And if I'm trying to find BC, that's going to make use of this other opposite piece going on here. Okay, let's set this up. We've got sine of 89 over 32 is equal to sine 30 over question mark. Sine of 89 is going to be really close to 1. So it's going to be 0.9998 over 32 is equal to sine of 30 was going to be 0.5 exactly over question mark. Depending on how you want to take this here, you might do a few different things. I'm probably going to evaluate the decimal on the left side first. That divided by 32 is 0.0312. We're going to multiply that by question mark, and that's going to be equal to 0.5. When I divide by 0.0312, we get question mark. So we 0.5 divide by 0.0312, and we get question mark is really close to 16, which in fact is going to be 16.0024. I'm okay with us leaving that as 16. And that's really what we're trying to do here, is just find that one measurement. For triangle AB, we've got to find both the area of this and we've got to find side AB. I'm going to look first to see if I have any opposite pairs. C, no. Let's see if I can make a terrible bone-shaped thing. B, I don't actually have both pieces. Same with A. So it looks to me like I'm probably going to have to use log cosines for this. This is a great log cosines problem. We're just trying to find C with law of cosines. So we can even use the one that looks the most like the Pythagorean theorem. C squared is equal to A squared plus B squared minus 2AB cosine of C. When I plug this stuff in, we get C squared is equal to 25 squared plus 29 squared minus 2 times 25 times 29 times cosine of 130. And I can literally plug that in as is. I don't have to worry about combining like terms or any of the things I normally have to be careful of. So 25 squared plus 29 squared minus 2 times 25 times 29 times cosine of 130. And we get that C squared is equal to 2398.04. Taking the square root of both sides. C is equal to 48.9698. If you're rounding to the nearest tenth, that's going to be 49.0. Okay, second part of this for the area. Our goal here would be to find some height for this triangle. And you can do that if you want to by extending this side. And it's going to be based on 130, so this would be 50. And using this as the hypotenuse of that right triangle to find the height. The other thing that I might be able to do is use that area formula that we developed as a replacement for this. And that would be that the area is equal to side, so that's side A, another side, side B, multiplied by the sine of the angle in between them. This is actually doing the same thing. The trick is that sine of 130 and sine of 50 end up being the same exact value. So the area is going to be 25 times 29 times sine 130. 25 times 29 times sine of 130. And we get the area is 555.3822. For the next problem, we've got something given just words for this. So let's draw that triangle. And I'm going to call this KHP. Angle K is 53 degrees. P is 37 yards. And K is going to be 35 yards. Alright, this is one of those cases where I might have some kind of an issue in this problem. What we're going to have to do to check this is first acknowledge that we have an angle and then a side and then a side. That doesn't follow our rules of things that we can do well. We do have an opposite pair. The problem is going to be we're not necessarily sure if this is going to be the biggest side or if this is going to be the second biggest side, and that's going to determine what's going on with our triangle. Let's go for the standard one first. So we're looking at sine of 53 over 35 is equal to sine of x over 37. I'm going to do sine of 53 divided by 35 times 37, and I get that sine of x is equal to 0.844. When I do inverse sine of 0.844, I get an angle of 57.564 degrees. So what this is saying is that one option for our triangle, that this could be 57.64 degrees. Okay. I can then use what I know about triangles, which is that they have to add up to 180. And in figuring this out, this top angle has to be 69.43 degrees. And that's because I can't read my own writing. This should have been 564 instead of 67 or whatever that was. Okay, so now we have something here. I can use this to figure out the third side using the same ratio. So sine of 53 divide by 35, and I get a value of 0. I'm not in the right format. There we go. 0.0228, and that's going to be equal to sine of h, which is 69.43 over little h. This is barely legible. I'm going to zoom out a little bit. I'm going to multiply both sides by h and divide by this piece here to get h is equal to, so that's going to be sine of 69.43 divide by that answer, 41.0306. 41.03. Okay. This is the triangle that we might expect us to get. And this would be one answer to this problem. The problem becomes that for this, with regards to triangles, there are actually two different answers. There's the standard answer of 57 that we got, and there's also the possibility that this is going to be just on the other side of 90 degrees. And to do that, the easiest way we can figure this out is going to try to be 180 minus 57.564. And if I do that, so 180 minus 57.564, we get 122.436. And just to verify, if you do sine of 122.436, you get 0.84399, so the same value we had, more or less, for the sine of 57. And what that really does for us is that's going to create a second triangle. That's going to create like this alternate universe triangle going on here, where we have 53 already. Now we've got 122.44. Using what I know about triangles, if I do 180 minus 53 and minus 122.44, this is going to be 4.56 degrees up here. It's going to be a really tiny angle. We're still going to have 37. We're still going to have 35. But now, in finding this third value, I can do the same thing. So sine 53 over 35 is equal to sine of 4.56 over some unknown value h. And when I do that out, so this is going to be that 0.0228 that we got above, sine of 4.56 is going to be 0.0795. If I multiply both sides by h and divide by that 0.02, so it's going to be 0.0795 divided by 0.0228. We get h could be 3.486. And the lesson from this is, please be careful when you have two sides and a not included angle, because we could very well have two different ways to do this. And sixth and lastly, a nice Shakespeare pun in there, we've got another triangle. This time we've got three sides. I don't have any opposite sides in angle pairs, so I'm going to use my law of cosines. I'll go for B first. In fact, I might even just stop at B, because this ends up being a very long problem otherwise, and we're already running long in terms of minutes while I talk a lot. I might set up the law of cosines from any angle, and again, I just arbitrarily chose B. And this becomes 25 squared. I'm going to zoom in a bunch. It seems if I write larger, this is being less fussy. So 25 squared is equal to 26 squared plus 19 squared minus 2 times 26 times 19 times cosine of B. Okay, 25 squared is going to be 625. 26 squared plus 19 squared. 26 squared plus 19 squared. We've got 1,037 minus 26 times 19 times 2. 988 cosine of B. Here is the part that we tend to get stuck on. You cannot combine those two numbers. Those are not like terms because the first one is a constant and the second one has a cosine of B. So instead what we're going to do is minus 1037 to both sides. 625 minus 1037. We get negative 412 is equal to negative 988 cosine of B. I'm going to divide by negative 988. Take the inverse cosine of both sides. By the way, that's going to be 0.417 is equal to cosine of B. The inverse cosine of 0.417 is going to be 65.35. You could have done the same thing for any piece of this. And in fact, you could repeat this for angle A or angle C. Or from this point, you could use law of sines, but it tends to be a little bit less arduous in terms of the amount of work that it requires. I'm not going to finish solving this for the sake of the length of this video.